In this lesson, we'll go over percent increase and percent decrease. Specifically, we'll talk about absolute and relative change. We'll identify percent increase or decrease, and then we'll correctly calculate those problems. I like to refer to them as markup or markdown. Absolute and percent change. So absolute change is the new value minus the old value. One way to think of new is most recent. Relative change or percent increase or percent decrease is calculated as new minus old divided by old, which will give you the relative or the percent change as a decimal. Notice it spells no if you need help remembering the formula. Negative percent change versus positive percent change. So if you do this formula and something has a negative percent change, it means that the most recent value is lower than the older value. Or if you have a positive percent change, it means that the current value or the new value is more than the old value that you were working with. So it's okay to have a positive or a negative depending on the context of the problem. Example 1, find the value of a condo which increased from $66,000 when it was first purchased 6 years ago to $109,000 today. Find the absolute change and the relative change. So absolute change is new minus old. Okay. So when I think of new minus old, particularly when I'm given years, the new is the most recent. So in this case, it's 109,000, and the old value is 66,000. Okay. Since the more recent value is higher than the old value, I expect this number to be positive. 109,000 minus 66,000, which gives us 43,000. Okay. So the absolute change tells us just the difference in value from 6 years ago to today. When we talk about relative change, we're looking for the percent increase or decrease. So we do new minus old. Divided by the old value. And usually it'll tell you where to round. So we take 109,000 minus 66,000 divided by 66,000. Now, does this number look like a percent? Not quite. Remember, it gives us the relative change as a decimal. So with this, you have to make sure to convert your answer to a percent by multiplying by 100. So this would be, let's say, 65.15%. So that's the percent increase, and it's a positive because the more recent value is higher than the older value. Example 2, a Nintendo Switch Mario Kart 8 Deluxe Bundle sells for $356.99. On Black Friday, the sale price was $299. Find the absolute change and the percent decrease from the regular price. So notice here, we're looking at a lower price than the original. So we should expect both values to be negative. Is new minus old or more recent? And this is also telling us too that the reference point is the original price. So that's going to be the old price. So we have $299.99 minus $356.99. Which would be negative $57. So for the special sale, it was $57 off. Now let's find the percent decrease. So it's new. Oops. Minus old divided by old. Okay, so divide by 356. So this gives us negative 0.159 and so on. And notice it's negative because the more recent price is lower than the original price. As a decimal, we'd multiply by 100%, and let's just say this would be negative 16%. So there's two ways to write this, negative 16% or 16% decrease. So either way, the negative's being accounted for. If you have a negative in your answer, that denotes that it's a decrease, or you can write the percentage, but just make sure you include decrease after. Percent change, markup and markdown. So these are prices or items changing from 100% of the value. So when we talk about markup, we're usually talking about like a sales tax. So when you go to a store, there's a price tag on the item, or if you're shopping online, there's a price tag. And then by the time you check out or you get your receipt, you end up paying more than what was on that price tag. And that's because after sales tax, there's a markup or the price is increasing. So the formula is new is 1 plus P times the old, where P is your percent as a decimal. Markdown is when something's on sale. So if items are 20% off or 15% off, that would be a markdown. So from the original price, the price is coming down by whatever percentage it's giving you. That formula is similar. It's new is equal to 1 minus P times the old, and P is always percent as a decimal. So markup is usually like tax, you're paying a greater amount, and then markdown is usually like a discount or a sale. So example 1, the retail pre-tax price of a textbook is $119.99. The local sales tax rate is 8.38%. What is the total price? Oh, I changed it from textbook to access code. After tax. In this class, they're kind of the same. Round your answer to the nearest cent. So this is going to be a markup problem because we're talking about a tax. When you're determining markup or markdown, think about whether the price is going up or going down. Okay, so our new value is equal to 1 plus P. So our decimal is 0.0838 times the old value, 119.99. So this is how we would get how much you would pay at the cash register, or if you bought it online, this would be how much money is coming out of your pocket. Okay, so I'm going to rewrite this as new is equal to 1.0838 times 119.99. So notice, just kind of as an aside, 1.0838, if you were to write this as a percentage, it would be 108.38%. So you're paying not only the price of the textbook, but the percentage on top of that as well. So that's where this formula is coming from. So you take 119.99 times 1.0838, and we're going to round to the nearest cent. So we would be paying, let me make sure I put this in right. $130.05. Sounds about right. You're paying more by the time you get out of the store or by the time you check out online than what was listed next to the item price. So this is the example of a markup problem. Example 2, an item. So pick an item that usually sells for $150. You see a sign that says 15% off. What is the discounted sales price? So this would be a markdown problem. In this case, the price is going to be lower than $150. So this is markdown. Okay, and then our percentage as a decimal is 0.15. So our new value is going to be equal to 1 minus 0.15 times 150. So new is equal to 1 minus 0.15 is 0.85 times 150. Again, if something is 15% off, you're paying 85% of the original. So that's where this 0.85 comes from. Put this in our calculator, and we get 127.5. So our answer makes sense. It should be lower than 150. Example 3. Find your hourly wage if after a 1.5% pay raise, your current wage is $13.25. So in this case, you're actually given the new value. Okay, and it's a pay raise, so we're going to be talking about a markup problem here because your current rate increased from your previous rate. Find your hourly wage. This would be find the old, and this would be 0.015 as a decimal. So in this case, we're given the new value. So our formula, let me go back to that. Our formula is new is equal to 1 plus P times old. So that's what I'm going to fill in here. But rather than solving for new, we're solving for old. So new is 1325 is equal to 1 plus 0.015 times our old, which is what we're not sure of. Okay. So in this case, we have 1325 is equal to 1.015 times we don't know, and we would divide both sides by 1.015. So we have 1325 divided by 1.015, and typically with money we round to the nearest cent, so our old would be $13.05. Okay, which makes sense. This was your old rate, so $13.05. You got a little bit of a raise, and your current rate is $13.25. So kind of as a wrap up here, absolute change gives us the value, just the number value change, not dealing with a percent. It's just new minus old. When we talk about the relative change formula, new minus old divided by old, you typically use this one when you're looking for the percent change. So if you're given a problem and it says find the relative change or percent increase or percent decrease, you would use the relative change formula. When you're looking at markup markdown, so you're paying a tax and that's being added onto the original price, or the original price is coming down, that's when you would use the new is equal to 1 plus p times the old, or the new is equal to 1 minus p times the old. Technically, you could use any one of these formulas for relative or markup markdown, but they're just in a little bit of a more friendly form to work with depending on what you're asked for. If you have any questions, please feel free to reach out to me.